Hello, I'm Philip Muggleston, and in this series of videos we're covering the predictive capabilities native to SAP HANA. In this video we're going to look at linear regression. As you may have seen in the previous video, linear is where we represent effectively a straight line that most closely fits across our data points. So perhaps something like this. What we will do with the PAL is first we will build the model basing income as the explanatory variable and using spend as the dependent. Once we've built that model, we will then feed some income values into the PAL and it will then apply the equation. Effectively, it will calculate the spend values for us. So now we're in HANA Studio. Let's look at our source data. We're going to use the customers dataset that we've already seen in a number of previous videos. We can see we've got lifetime spend, more recent spend, income, and a loyalty index for each of our customers. And if we were to chart that, let's perform some quick analysis. And we were to plot the income against the lifetime spend and to scatter plot. What we can see, these are the values of income, and we can see the lifetime spend. We can see there seems to be a little bit of a trend line, seems to be going kind of even a fairly straight line. So maybe linear regression is useful in order to allow us to predict future values of lifetime spend based on the customer's income. So let's start to look at some code for how we can go about doing this. As we've seen many times, we need to use the PAL, first to use the wrapper generator to create a procedure, and then later we'll call that procedure with our actual data. Now you can use the PAL area, which is our schema in this case, to store the types and the signature table, and then you can call the wrapper generator with those tables and types. Now, for regression, we have quite a number of different parameters to put into the wrapper generator. Effectively, we're going to have two different input tables, the input data and the parameters that we've seen in pretty much every other PAL algorithm. However, for regression, we have up to four different output tables. One of them is called coefficient, there's one called fitted, one called significance, and one called PMML. So we'll see in more detail later exactly what each of those does. But we've created our definitions, which are pretty much standard definitions for these. We've defined our input data to show the lifetime spend and the income with an ID to represent each row in the data. So we can call our wrapper generator using that signature file with those table types and let that be created. So now it's been created, we can go more to the application setup. In this case, we need to actually define that input view. So we can simply create an easy view with just the columns we need in the right order, where we can see we have our explanatory variable second and we have our dependent variable first, both followed by the ID. And we'll create the tables in the same structure as the table types for the input and output tables. And what we can also do, we'll see later, we might create just a little view that takes the fitted data, because the model is actually going to show us the actual data fitted to the line, and actually join that together with the actual data that we saw in the beginning, so that we can maybe just do some analysis, some comparisons of our model. In terms of parameters, there are basically three parameters that we would use. There's the thread number that we've seen in many predictive analysis algorithm examples, the number of threads to use, it's a tuning and performance value. Variable num is where we specify, specific to regression, how many explanatory variables we've got. So this is a simple example where we're looking at just income as the explanatory variable. So we set the value to 1. And in PML export, we can set the value either to 0 if we don't want any PMML being created as the model, or if we do, we can set it to 1 or 2, as we've seen in previous videos. So we can now run that code, and off we go, and it runs successfully. Now that we've created that, we can actually go ahead and actually build our model. So we just clear out the tables in case we'd run it before, and then we call our procedure, which we've called in this case PAL_RG for regression. And as always, the procedures are stored in the _sys_AFL schema. So let's run against that source data, and we see that the procedure runs very, very quickly, even potentially on a large volume of data, because after all, this is HANA. So if we're now to refresh our list of tables, we'll see that some new tables have been created. We created them, in fact. We can see, for example, we've got the signature table, but more importantly, we can see we've got the coefficient, the fitted, the parameters, and the significance, also the PMML. So let's have a quick look at those. So effectively, the coefficient table shows us the equation that's been created. So effectively, the AI value, or A1 to 2, 3, 4, 5 value we've got, gives us the value we will substitute into the equation if we wanted to calculate the values for lifetime spend ourselves. However, we don't actually need this ourselves because the predictive analysis library will calculate or will predict the values for us using this. So this is really more for informational purposes. And we can also see the significance. And the significance is where we get to see the values that's been calculated for R squared and also for F. Now, in the introductory video for regression, I talked a little bit about what R2 and F mean. So we can see here R2, or the R squared value, is 0.75. So between the value of 0 and 1, where 1 would be a very good fit, a perfect fit, we can see it looks to be a pretty strong, a pretty usable value, so maybe a good fit. However, we also need to take into account the F value. So we can see here we've got an F value of 468. Now, how do we put that into context? Well, we need, as I explained in the previous video, to look at that value in the context of the size of the sample that we're working on, which in this case was 150 customers, the number of exploratory variables, in this case it was 1, and we also now need to look up a value of F based on those values in what's called the F distribution table. Now, either you've got some tables lying around handily or you haven't. In my case, I don't. So what I'm going to do is I'm just going to go onto the web to one of many places where you can actually get access to the F distribution. So I'm going to stattrek.org. And what I can do here is StatTrek, I can go to stat tables and pick out the F distribution. And now I can enter my values that we saw. So we had first degree of freedom. I haven't gone into too many details, but for now this value is set to 1. Then the second degree of freedom is actually the sample size, which was 150 rows, minus the number of exploratory variables, which was 1. That gives us 149, minus 1, which is a constant. So actually our value here would be 148. And then we can specify our probability. Now, in terms of a result that is significant, we would want to look at the 95th percentile. So in this example, we'd put in 0.95, hit calculate, and we'll get a value for F. So we see for a significant result on this data set, we'd expect to see an F value of 3.9. In fact, our value is 468, so far above it. So that's a good sign. But in fact, if we want to know whether it is statistically very significant, then we would need to go to the 99th percentile, recalculate. And again, here we see a larger F value, 6.81. However, our value being 468 is significantly more than that. So we can say that we have a very significant model here, statistically speaking. So we've looked at R, the R squared value, we've looked at the F value. This model seems to make sense for us. So what we might now want to do is to actually predict some new values for the lifetime spend. So for some incomes that we don't already have. So here is a second piece of code. And again, we need, as always, to create a procedure using the wrapper generator as part of the application function library. So here we've got the code, and it's very similar to what we already called. We need to input the data, which actually is going to be just an ID value that we set up, and then our income value. And what we're going to get out of this is the lifetime spend that's being predicted based on our model. So we are going to have one output table, which is what's called the fitted table. We need to provide the actual model. So as well as just the data, we need to provide the coefficient table, which is the one we were just looking at, which actually has the values in it for the equation. And then Predictive Analysis Library will use that and actually will create, will fit to that model our results. In the case of the formula we need to use, in this case we're using what's called forecast with, and then because it's linear regression, we're putting an LR on the end. So that's the name of the algorithm that we're going to call with the PAL. I forgot to mention that, but when we were calling originally to do linear regression, we always put a regression as the name of the algorithm we want to call, and LR is what we use for linear regression. So in this case, we're going to do the forecasting, so we're going to go forecast with LR, with linear regression. Let's run that code to generate our procedure. So that code's executed. We then need to just set up our data table and our results table, and we'll create a view where we just join these together so that we can get some good analysis afterwards. And then it's our turn to actually go ahead and do some prediction. So what we need to do are to create some variables, some values that we want to be predicted. So we may create a couple of new rows, 151 and 152 in our data, with an income value of 2.5, and for the next one, an income value of 7.5. So let's create that in the data. That's our source data for the prediction. And then we run our prediction algorithm, giving it the coefficient table, giving it this input values to be predicted, and the parameters. And we will get the results out in a table, which is actually called RGP predicted. But then we'll probably use the view where we join that raw data with something a bit more substantial from our source data. So if we were to just refresh, we'll see we've got some new tables. We've now got a RGP underscore predicted. So if we were to just quickly browse that, we can see those are the fitted values, the values for lifetime spend that are coming out from the input data for income that we gave. However, that's kind of a bit raw. It doesn't really give us a lot of detail. And that's where it's good that we can use this view we created, which simply is joining this predicted data with the actual original data set and also a little bit more information so that we can get a bit of a better view. So if we go to our views, we can see we have a view of predicted. And in this case, we can see we've got our ID, lifetime spend and income for all the original data plus the values for 151 and 152, which are the two that we've just asked to be predicted from the model. And of course, like always, we can now chart that. So we may go and put income against lifetime spend and do that as a scatter. And we can see now, compared to the original one right at the beginning when we saw this source data, we've got a couple of new points. We can see here we have ID 151, and that is where we can see the value that was predicted for lifetime spend as predicted as 5.3 based on us providing the income value of 2.5. And at the end here we can see a second example, which is 152, where we can see from the lifetime sum we have a value of just over 7, and it gives us the value of, again, just over 7, interestingly, for lifetime spend. So we can see now we've got our predicted data in the context of all our data.